The spinning system that inserts the false twist is ring spinning, compact spinning, air jet spinning, or air vortex spinning. So before coming to these false twist, we need to know the different types of spinning system. It is a 1 mark question that is asked. Now what actually the gate, the pattern is very much changed from the previous years. So now the questions are very much conceptual. You need to know the basics first, then you can answer the questions. So the options that says that ring spinning, compact spinning, air jet spinning, and air vortex spinning. So in case of air jet spinning, what happens is air jet spinning uses high pressure air stream to wrap fibers around each other, which each other pour yarn. Then they introduces this type of by use of high pressure air stream. High pressure air stream is used to insert the false twist into the fibers, while it is used to hold the fibers together. Whereas in case of what happens in case of ring spinning, it uses a ring and a traveler to twist the fibers. Ring and traveler is used. Ring and traveler to twist the fibers. Whereas in case of compact spinning, what happens is it uses a compacting device. Which type of compacting device is used? Why this is used? This is used to reduce the yarn hairiness and the strength of the yarn. So, and the last one is air vortex. So air vortex uses a high speed air vortex to twist and wind the fibers together. So these two are generally, most of the things are same, but in case of air vortex spinning, it does not use the false twist to twist the fibers, whereas in case of air jet spinning, it uses false twist to hold and twist the fibers. So the question says that the system that uses only the false twist, that inserts the false twist, so it is air jet spinning. And this false twist is not inserted in the ring or compact or air vortex spinning. So option C is the right answer. So these are the types of questions that the gate generally asks. In a bobbing leading roving frame, the correct relationship between spindle speed and the bobbin speed is. These are the 4 figures that are given: A, B, C and D. So if you look at the figures carefully, then you have to answer that the relation between the spindle speed and the bobbin speed means the bobbin speed is higher or the spindle speed is higher. So if you know that in a bobbing leading roving frame, what happens in a bobbing leading roving frame? Bobbin speed minus spindle speed is equal to wind on RPM. So if we say that wind on RPM is front roll delivery upon pi d. If you know that in a bobbin leading spindle frame, roving frame, the bobbin speed is higher. So the bobbin speed should be higher for constant spindle speed. The spindle speed is constant because the wind on RPM is remains the same due to front roll delivery and the diameter. So in this case, the bobbin speed will be higher for constant spindle speed. So you need to select the bobbin speed should be higher. Here the bobbin speed is lower, so this cannot be the case. And here the bobbin speed is also lowering and the spindle speed is also lowering, whereas the bobbin speed is higher than the spindle speed. Here the bobbin speed is higher than the spindle speed. So if you look at the things carefully, so when in option number A and option number C, you can see that here the bobbin speed increases, but as the bobbin diameter increases, then the bobbin speed decreases. because you know that diameter is inversely proportional to the speed. In these particular cases, here the diameter increases, the bobbin speed should be lower and the spindle speed should be constant, because the cases of bobbin leading roving frame. Here the bobbin speed is also increasing, so it is not the correct answer, and option C is the correct answer, where bobbin speed increases, bobbin diameter increases and the bobbin speed decreases and the spindle speed is constant. So option C is the correct answer. I think it is clear. If the twist factor is same for a set of cotton yarns, then the yarns have same linear density, turns per meter, packing density and angle of the twist of the surface fibers. So you know that for the twist factor, if it is same, then tan alpha is equal to 0.112 into under root Vy into Tf. So if I talk about this, then you know that Tf is equal to tan alpha into under root of rho y upon 0.112, since Vy is equal to 1 upon rho y. Then if the twist factor is same, then the angle of the twist of the surface fibers and the packing density would also be same. If says that if the twist factor is same, then this angle and the packing density of the yarns is also same. So in this case, these packing density and the angle of the twist of the surface fibers, these two are same. So option C and D is correct. So basically you need to know about all these things in detail. 0.0112 into rho y into Tf. So I think this is clear. So this is a multiple type of question that is asked in GATE 2023 textile. Now what happens is in this particular year, the multiple choice questions increase. That increases the difficulty level of the GATE examination. So this paper was considered a very typical paper as compared to other GATE questions. It says that if the twist multiplier in the indirect system is 4.8 TPI per NE, then the twist factor in the direct system TPM root text rounded off to 2 decimal place is. Then how we need to find out this? Here what it is given as, this is a yarn manufacturing question. This is a 2-mark question, and if we have to calculate how this we need to do, then the TM that is given as 4.8 TPI upon root NE. If we have to convert this into the direct system, that is text, then how we will this per inch, TPI is twist per inch. So if we have to convert this into direct factor, then this is 4.8 twist per inch. If we need to calculate into meters, then it is 1 upon 39.37 meter into this NE is if we need to convert this into text, then what it would be, you know that text is equal to 590.5 upon NE. Then how we need to convert this? For NE is 590.5 upon text, 590.5 upon text. So if we will solve this, then it would come out to be 4.8 into 39.37 into under root of this is 24.3. If you will calculate this, then it would come out 39.37 into 4. If you will do this, then You can do this by using the gate calculator. Then if you will calculate, then it would be come out to be 188.976 into 24.3. Using gate calculator you can solve this. It would come out to be twist factor is 4592.11. So this is the correct answer, and the gate that the official answer was accepted in the range 4591 to 4593. So this is the official answer key, and this is the correct answer that you need to calculate. This is a 2-mark question. It is also yarn manufacturing question. It is of carding machine. There are 4 statements that are given for the carding machine, and you have to find the thing that is given in the question. It says that lowering surface speed of the feed roller, increasing rotational speed of the taker in, increasing linear density of the feed material, use of shorter and finer fibers. So the correct combination of the above activities in order to obtain more number of taker in teeths acting per fiber is. So you have to find this. If we talk about which is the correct combination, so when you lower the surface speed of the feed roller and increase the rotational speed of the taker in, you just consider this carding diagram that you see here. This is the main part, and this is where the carding action happens. So feed rollers, it comes to the feed roller, it is a cylinder, and the tufts goes from here to here. If you decrease the surface speed of the feed roller and increase the rotational speed of the taker in, it increases the number of the teeth acting on the fibers per unit time. So when this is increased, it thereafter directly influences the efficiency of the carding process and increases the carding efficiency. When the carding efficiency is increased, then you can say that it occurs in better carding action. So better carding action means better carding action means directly the more efficiency, which results in good amount of the fibers that is coming from the carding machine. So according to the question, option number P and Q is right. When you decrease the surface speed of the roller and increase the rotational speed of the taker in. So this is the correct option. Option number A is the correct option. I think it is clear. Coming to the next question, it is of combing machine. It is also a yarn manufacturing question, and it says that in a cotton combing with respect to the timing diagram of cotton combing machine, options are given as in forward feed system, feeding mostly take place when nippers are closing, cylinder comb starts combing after the feeding ends, detaching roller move backward during the forward movement of the nipper assembly, the top comb is not combing when detaching rollers move forward. So if I talk about all these things, the correct combination of the two statement is, so if you remember about the combing machine, what is combing? It increases, it basically, it is a luxury process. It increases the feel and the softness of the cotton. So combed cotton is generally more have more softness as compared to the carded cotton, because the combing action is done. It is a specialized process. It is not a compulsory process that occurs in during every process of the machine. So in cotton combing, in the forward feed system, feeding take place when nippers are opening. So this is the wrong. This nippers are opening, they say. So this is said that nippers are closing. So this is wrong. And if I talk about the cylinder comb, when it starts after the feeding of the cotton is completed, as the cotton has to wait for the feed rollers to stop delivering cotton to the machine before it can start the combing process. And the top comb and the detaching rollers work together to remove the combed fibers from the cylinder comb. So if you see all these things on a particular basis, then you can say that the cylinder comb starts combing after feeding ends. So option Q is correct. And detaching roller move backward during the forward movement of the nipper assembly. So this is also right. Top comb is not combing. This is wrong. So option number B is the correct option. I think it is clear. It is a yarn manufacturing question. It says that drafting force in a draw frame when fibers are sliding reduces with higher draft roller setting fiber length number of fibers in the feed sliver. So if you know that increasing the draft or reducing the draft roller draft can decrease the friction between the fibers and the roller. So if the friction is decreased, the drafting force is reduced. So this is how these things are happened. So option number A and option number B is the correct option. Draft and roller setting. Drafting force in a draw frame when fibers are sliding reduces with higher draft and roller setting. So option number A and option number B is the correct option. So this is also multiple type of question that the trend for these multiple type of questions have increased in the coming time as far as the things are concerned. Now coming to the next question, I think this is done, and this question, this is the fabric manufacturing question. It says that the force exerted by the reed on the cloth fell at the instant of the beat up weaving resistance depends on. So these are the four factors that are given: free length of the warp yarn, elastic modulus of the loom state fabric, elastic modulus of the warp yarn, and elastic modulus of the weft yarn. So basically there are two things: warp yarn and weft yarn, and their modulus. Warp and weft yarns and their modulus, if I talk about this. So when you know that the free length of the warp yarn directly affects the tension and the interlacement. Free length directly affects the tension between the yarns, and the interlacement between the warp and the weft yarns, and due to this state it directly affects the weaving resistance. Weaving resistance means the difficulty caused to resist the weaving, means fabric manufacturing process. The elastic modulus of the loom state fabric in the warp yarn, it determines the stiffness and the ability to resist the deformation under the applied load during the process of the beat up, and it directly affects the weaving resistance process. So if I talk about the warp yarn is basically all responsible for all these things. So the free length of the warp yarn, it affects, and elastic modulus is affected, and the elastic modulus of the loom state fabric is affected. But the elastic weft yarn does not participate in this weaving resistance process, as it is defected, because the warp yarn only determines the stiffness and the ability to resist the deformation in the applied load during the beat up process, and the weft yarn does not take part in this process. So basically this is important. I think option number A, option number B, and option number C is the correct option. I think this is clear. It says that a 36 NE ring spun yarn is produced from 1.2 NE roving. The total draft and the break draft of the roving frame are 12 and 1.2 respectively. The diameter of the back bottom roller, middle bottom roller, and the front bottom roller of the roving frame are 28 mm, 25 mm, 28 mm respectively. If the middle bottom roller of the roving frame is eccentric, then the wavelength in meter of the periodic fault in the yarn, neglecting twist contraction, rounded off to 2 decimal places. So it is a 3 by 3 roller, drafting roller, that is given as this. So the difference between this is 1.2, and the total draft that is given as 12. So in ring spinning, it is said that the final that yarn is formed is 36 any yarn, 36 any count that is finally formed, and these are eccentric rollers. The diameter of all these things are given. So you will have to calculate the front draft, and then the actual draft, then the wavelength. So wavelength is basically total draft into pi d. You know that the wavelength is total draft into pi into d. So yarn count is 36 ne, yarn count is 36 ne, and the roving count, since this is roving, 1.2 ne, and finally after these rovings, these 36 ne count is formed, and break draft is also given as 1.2. So you will have to calculate the front draft. What is the front draft? So front draft is basically the total draft, that is 12 upon the break draft, it is 1.2. So the front draft is 10. And what is the actual draft? Actual draft, in case of indirect count, you know that it is delivery by feed, and in case of direct count, that is takes, it is feed by delivery. So in this case, it is a delivery by feed. (36 upon 1.2), it will come out to be 30. And the wavelength of the periodic fault you will have to calculate, then it will come out to be wavelength is pi into d into total draft. Total draft we have calculated as 30. So pi into diameter is given as what is the diameter that is given in the question? I think the diameter of the diameter you will have to calculate. This diameter of the middle bottom roller, it is 25. So the diameter is 25 mm. So 25 mm into meter is 1000 meter into total draft, that is given as 30. So wavelength in meter you will have to calculate, and then the wavelength in meter will come out to be 23.56 meter. And please check it is in 2 decimal place or 1 decimal. 2 decimal place. So this is the correct answer. I think these questions are clear. These are a little bit tricky, but you will have to focus on the basic concepts of this, and the idea to solve all these questions is basically concentrate on what is asked, and then focus on a step by step manner, because the idea is same. In this question we have to calculate the total draft, then the wavelength is pi into diameter, and then multiply by the wavelength and basically in meters. So I think this is clear. Now coming to the next question,